I'll go ahead and jump in. And I'll start off with an introduction. So, who am I? My name's Jeremy. I'm currently working as CTO and co-founder at Allstacks. And we're building a tool that help other organizations build software better. We do this through instrumenting all of your platforms and providing you data and ability to make decisions to better build product, better optimize your teams, better optimize your processes. And I got into this because I've been around the block a little bit. I started off as an engineer. I got into a number of different startups, and I have either been the first engineer or led engineering at 4 different companies. I also have a background in computer science and machine learning, which drives a lot of the way I look at the world. And I'll actually get into this in a little bit. Some of that has actually flavored how I've structured this talk. So feel free to ask me any questions about Allstacks at the end. We're here to help you about all that, but I'll get into the meat of the talk. So this talk is actually about surface area, and I will get to that, I promise, but I want to start with a little bit of context. We're all probably well aware of the agile software development revolution and how that has sort of led into a number of other things like the DevOps philosophy. But I think at the core of agile, it's actually a really strong way of building software. It takes the core understanding that we can't fully know exactly what we're building at the beginning of a project. We have to iterate. We have to work with customers and stakeholders. And that iteration actually produces a really great product at the end of the day. It allows us to optimize our focus. It allows us to select what we work on and be able to switch between various things as priorities change. For all of its benefits, there are actually some interesting risks with this approach. Focusing on delivering best iterations possible is very healthy. Sometimes you actually have to look as an engineering leader and a technical leader, even product and company leaders. You have to look beyond the current iteration to make the best decisions for what you're building. And herein lies some of the tension, and one of the reasons that we actually developed surface area. So I love this quote from my undergraduate economics class. Didn't go much further than that, but rational people think at the margin. And that's actually one of the driving principles behind why Agile ends up being really effective. It allows us to make the best decision for ourselves right now. And if we continue to do that, we actually arrive at a really good place most of the time. One of the things that we can actually do wrong in this process is we can get stuck at local minima or local maxima. If we continue to think about iterating one step at a time, we may end up getting stuck in some of the valleys between the peaks of where we actually want to go. And I mentioned earlier, I have a background in machine learning, and gradient descent is actually an algorithm that I think describes this process really well. So I'll describe this a little bit so that you understand where I'm coming from here. And I promise I will tie it back in a second. Gradient descent is a very simple algorithm at its core. It finds minimums, generally speaking. I love to think of it in terms of you start on a mountain and your goal is to actually get to the very bottom. Let's say overnight fog came in and you can only really see 2 steps in front of you. So what's the best way in that scenario to get to the bottom? You may not have a map, you may not have a trail. So the algorithm basically says we'll pick the direction that takes us down the lowest. We'll go down the steepest path, and we'll continue to do that with every step that we take. And that works until we get to a local minimum. We may be able to get further down if we would have picked a slightly different path, but now the algorithm has sort of gotten us stuck a little bit. And I think this particular iterative way of thinking ends up being the exact same way that iterative software development methodology can drive us towards if we're not very careful. And what we have to be very aware of as leaders, technology leaders, product leaders, any leader in a company, is identifying when we get to one of these local minimums and realizing that we may have to take a slightly irrational path to get over or around where we're stuck at. And I think the system is a really good a really good corollary to how people tend to work together, because it's actually a good algorithm. And Agile is usually a really good process staffed by really well-intentioned people. And even in these really good systems, we can actually arrive at these potential sticking points. And it's up to us as leaders to identify that and get around it. So, tying all of this back together, what I actually want to focus on in this particular talk is this philosophy actually comes down to how we build software and the actual product that we produce. While I think it has broader applications, I want to spend some time talking about some of the ways in which we can potentially get stuck, some of the ways in which we can actually get over it, and helping to identify between the two. Because sometimes advocating for these sort of irrational solutions can feel very unnatural. And it's really easy to argue that we may not be picking the best path. So this is where surface area comes back in, which is the lead line that drew us all in. And one of the things that we run into as engineers is we start to feel over time that our code may be getting hard to work in. We may be building up tech debt. We may have made a decision 6 months ago that makes things harder today. And a lot of that stems from the fact that we're making these iterative decisions, trying to find the best way to deliver the most value at the lowest cost. And, when we look back at a process that is very iterative, we may find that we've built a very strange looking house. We may have delivered on all of the features that we said we're going to do, but if we take a step back, it looks a little weird. So this house up here, it's actually a random image I found online that has just been added to over and over generations. And with different styles and different ways of thinking, different people adding things in, we compare that to some very well thought out, well architected house. And clearly, one of these looks a lot better. So I think maybe if you've been around the block a little bit, you'll probably be raising your hand and say, well, we can't actually sit down and plan 1 year's worth of product to build something like this amazing mansion at the beginning. And you're right. It's not worth it. It doesn't actually make sense. We know that things are going to change. And what I actually want to think about is, how do we avoid some of this craziness? How do we identify when we need to invest in rebuilding, restructuring? And in each iteration, how can we bake in thinking about the end goal in a way that isn't overly prescriptive or overly architected? And I think generally, as we go through these iterations, if we're not aware of how we iterate and how we build and think about a couple of steps ahead, we will accumulate surface area, we'll accumulate potential issues, we'll accumulate tech debt. And as we start to build this up, it can slow us down overall. So I think we're all really well aware of some of the decisions that may have been made in the past in our software products that are now biting us. And they can be many and varied, but they all usually net out as actual business risk. If we have a system that has too many moving parts, we could have a high bug rate. If we have a system that has way too many lines of code or is overly complex, it can take a long time to deliver features in that area. And these are all things that we didn't build intentionally. They were just interesting side effects or local minima of a really good process otherwise. So I call this surface area because usually what these issues net out as is there's usually too much of something. It can be too many lines of code. You could have too many servers to manage for your team. You could have too many frameworks in your application, too many APIs all doing similar things, too many microservices. In fact, I actually have a friend who's a CTO at a company that I consulted with a long time ago. And he helped me develop kind of a personal motto of, I don't really ever want more unique microservices than number of engineers that I have in the company. It got a little crazy, and getting started in that environment ended up being quite difficult. And made the fan on my machine were within 3 minutes of trying to do anything. And I think we're aware of these types of problems when we see them. And looking back in retrospect, it's easy to identify. What's actually really hard is translating that risk into the business. I know I've been guilty sometimes of advocating for something that seems absolutely crazy to almost any other stakeholder. So we need to rewrite this part of the code, and no one really understands, and I may be really bad at communicating why. And in my own mind, I understand the engineers that work on it are struggling. We actually have a really high bug rate. I know whenever I've talked about building small features, we get them done and we ship them, but it seems unnecessarily hard or complex. And the next time we have to work on a feature in this area, I know that the estimate's going to be twice the number of story points or 2 times longer, just because the team is starting to struggle to understand it. There's too much surface area to grok. And all of these things that we, I think, intuitively understand as engineering leaders, we have to translate into business risk to properly advocate for them. And I think this is actually where a lot of people struggle. And one of the things that I want to spend some time in a few more slides talking about, technical leaders a lot of times get viewed as being purely or technology and engineering teams oftentimes get viewed as being purely in service to product, or purely in service to what leadership decides we need to build, and oftentimes feel like they're struggling to advocate for things that make technology better. And while some of you may have figured out ways to do it, I think it ends up being a hard problem. And I think in a lot of ways, there is a trope that engineering leaders are often not as good at communicating as most other people in the business. And it may be hard for us to sell why we think refactoring this code is important to the company, as it is for a product leader to say, hey, building this new feature is going to gain us 20% more business. Even though both may actually have significant impacts to how the business operates and is able to move and be agile in the future. And one of the things about being able to manage surface area is advocating for the time to address these problems. We have to identify them, map them to business risk, and somehow find the time to work on them, as well as also delivering on our other commitments to the business. And we also have to do it in a way that doesn't over-rotate on building something that may be technically, or from an engineering perspective, super complete and super compelling, but avoids any of the actual business values of building new features or getting into new markets. And it's a really hard balance to take, because going back to agile and iterations, being able to iterate, test out things, move fast is really powerful in the market and for the business and for the company. And we have to be judicious at when we advocate for, hey, we know this process is working and can actually have a lot of value, but we need to do something seemingly irrational to move the needle and actually significantly improve our ability to build software. So I'll actually pause here for a second to ask some questions and see if there are any that are coming up. The next couple of phases, I actually want to go through some examples and talk at a high level about some approaches and strategies. But are there any questions so far about the way I've approached surface area and some of the risks that people have seen?
I think we're good.
All right. And feel free to ask questions in the Q&A box in chat. Paulo has agreed to help me call those out, because I am only on one screen and have trouble looking at this box. But I'll be happy to address these now or at the end. So yeah, I'll start with, in this section, I'll actually spend some time talking about some of the problems that manifest from having a high surface area. And the reason I want to go through these is I want to try and help us translate these into business risk, talk about exactly what kinds of impacts they could be, and maybe equip everyone here with better ways of talking about and advocating for these potential problems. And I'm keeping these intentionally at a slightly higher level without concrete examples, because as I go through these, I would encourage you all to think about, are there places in my own company or in my own work that I see this happening and have struggled to actually advocate for it? I know while I was writing this, I had an example in my own work of every one of these that I've seen or that's happened. And a lot of these stem from things that I've had to do in the past to get around it or communicate why it's important. So feel free to ask questions at the end or about specific examples, and I'll be happy to get into it. So I'll start here with the first problem. And one of the problems that can stem from having a very high surface area in your application is your team can have low familiarity with the entire product. And that can range from, not actually knowing what your product does to not having technical coverage over all the technologies that you have, or code that has been in production longer than your oldest engineer has actually been at your company. And those types of risks can be really hard on the business. And it shows up in some really fun ways. Two of these examples here, if every feature that touches parts of your code base requires like significant spiking or requires a lot of investigation or always gets high story points that because people just don't understand it, that can actually be one of the symptoms of having a very high level of surface area. And what ends up happening is that everything just takes longer. The business feels, feels things like, why does a text change take 2 weeks? Or why does this bug that seems like it's just, or this task that's just adding a field take, 4 engineers to look at? And those types of things can be frustrating and it can slow us down. Another potential symptom of this is lack of ownership. There's 2 flavors of this. Engineers may specialize in their own domains if the surface area is too big for them to actually understand the full code base. And they may also be unwilling to explore. There's just too much there. There's too many moving parts. And people can oftentimes try to find other engineers that are more familiar, start defining domains, and you lose team cohesion when that happens. You're not working together. It's a series of engineers that are starting to work on basically entirely different code bases. I'll get to some strategies for breaking these down in a second, but that's something that there's a number of ways to get around. The second problem I call tendrils, and all of these are somewhat related, but the first is that if you find that everything that you do requires touching a lot of code or a lot of services, or like a vine tendriling up a wall, it goes deep and through the app, and you have to touch a lot of things for relatively small changes. You end up having not only hard to develop code, but potentially fragile code or code that can have a lot of side effects. This type of high coupling, to get back to some software engineering concepts between components and services, means that it's just hard to design and hard to think about the problems. And this can, again, slow down the team, cause higher bug rates, and result in fragile code that we tend to maintain and avoid working on. A similar but slightly inverse problem is that there can be side effects to a lot of stuff. Making a seemingly innocuous change to an API may end up breaking something that depended on a bug and wasn't really documented, or we've had to move very fast and take advantage of unintended effects of things that were eventually called a bug, but we were using as a feature somewhere else. Sometimes these can be trivial, like breaking style sheets and changing fonts. sometimes they can take down production. Um, I've worked with various database engines and queries where if we even slightly change the order of operations, it actually creates some sort of race condition at our database level, our database layer, and breaks our ability to authenticate into the app. And those types of things are very symptomatic of, moving fast, trying to build things too quickly, and maybe not fully understanding the complexity of what we're working with. And the third one here that I want to touch on are distractions. Your team ideally should be very focused in each sprint, building something really cool, working together to deliver on a lot of value for customers. And oftentimes, if you have a lot of surface area in your code, you end up getting distracted. You can either be distracted by escape defects, so lots of bugs that come in all over the place, just because the number of bugs you have is going to be proportional to the amount of product that you have. If you have more product than your team can realistically support, your team is going to start to feel like they're drowning at some point. And that's going to impact our ability to actually deliver on software. So keeping a good eye on, how much work you're working on in each sprint that is planned versus unplanned can help you understand what your capacity is for actually doing work. If that starts getting over a certain level, you may not actually be able to ship any value for product, and your company may start to grind to a halt. Another version of this is if you have a very fragile code base, you're constantly having to maintain stuff. It ends up being very fragile. You may have a lot of manual tasks that have to happen. Like every time you do a deploy, you have to run these 3 scripts or else nothing will actually propagate. Or every time we update this configuration file, we actually have to go in and update 20 others because something's not propagating automatically. And those types of tasks just feel like they're part of the dev process, but end up making something that feels trivial take a very long time. And a lot of times, with well-designed and well-architected code and taking the time to rebuild some of this process, you can save a lot of time for the team. And of course, that nets out to a much happier company feeling like you're able to do more with less. So before I jump into some of the strategies for addressing this, I'll check again for questions, and feel free to ask at any point in time. But it looks like there are none so far.
Yeah, we're good.
Awesome.
We're good so far.
So I'll hop ahead and, I talked through a couple of problems. There's potentially many others that can come out of having a high surface area application, various things that can break. But I want to spend some time talking about if we find these problems, if we identify these problems, one, how can we avoid them? And two, how can we advocate for fixing them and what can we do? One of the things I wanted to focus on in this particular section is how do we avoid them in the moment? How do we think about how we're developing software right now, this current sprint, this one ticket that we're working on, in a way that avoids these issues in the future? Oh, lost my mouse. There we go. So the first approach here, I have 5 of these that I'll talk through. Split things up. If we are working with a very large code base, if the team is not able to fully understand what any one piece they're working on, if it's not able to be loaded into working memory and processed by a single team or potentially even a single developer, it's just too complicated. Taking the time to split these things up leads to a reduction in some of these issues that I've talked about, breaking apart the code, breaking things into microservices, even starting to define domain for teams here, and specifically calling out ownership can improve our ability to move faster and reduce issues. Some of this can be driven by staffing concerns as well. And breaking this up allows developers, even a small team, to be able to pick up independent pieces at a time, work on them, and put them back down before they move on to other pieces of even very large code bases. And if we have very good contracts between these parts of the technology that are simple, easy to understand, it's very easy for us to pick up any one piece, work on it, make a change, make sure that the contract is honored or modified in a very consistent way, and put it back down and have a lot of confidence that it will work as intended pretty consistently. Again, for larger organizations, as I mentioned in the beginning, my bias is towards how we grow startups. As you grow, your technology is obviously going to grow, and you have to split your teams up. As you define domains for teams and you figure out how they grow, making sure that those match to either product lines and technology lines can help us avoid some of these issues, especially code that ends up being very Tendrily. If you have a team that is sort of critical path for most of your changes, it's probably a good time to try and break that apart, move all of the things that each team needs to be successful to live within that team, within that team's repos and purview, and start to define better contracts between how they work together and communicate. Also advocate here for, reuse everything. By training, I'm a Python developer. And one of the standard mottos in how Python was developed was don't repeat yourself. So creating very dry code. I love that approach, not just in coding, but in architecture as well. So not only do you need to avoid throwaway code, but you also need to think about how you can reuse these technical components that you've already built. And this is maybe an interesting point. As technology leaders, we can advocate for how the product is built to some degree. Product is really great at understanding customer needs and may have very good reasons for asking for exactly what they need. But as technology leaders, if we come in and say, hey, if you make a slight change to this particular UX, we don't have to build a whole nother app or set of features or page. We can reduce the scope of this significantly. We can actually build a much better cohesive experience for the user that isn't as buggy, that's easier to maintain, that we can move faster in with very small changes to the actual product experience. And I think that point in particular is something that a lot of technologists that are new into the field struggle with. It's hard to advocate for, product is coming in with this wealth of knowledge and expertise, and you're just an engineer that joined a year ago, and you don't feel like you can push back. But taking the time to think about how we can do that as senior leaders and working together to build a better experience can lead to a better product, a better organization, and something that can provide a lot more value at a lot lower cost overall. And again, this applies, as I mentioned, not just to code, but to services, APIs, anything that you have in your technology organization. If you can make it a multi-purpose tool, if you can reuse it over and over, if you can optimize it, make it simpler, you can actually reduce a lot of potential problems. So similarly, if you're paying attention, approach 1 and approach 3 may feel like they're at odds. But they actually end up being two sides of the same coin. A lot of times when you end up having a lot of surface area in your application, it's because you have built 2 things that try to do the same thing, or 10 things that try to do the same thing, or 2 APIs that actually modify the same data model in slightly different ways. And as we're thinking about how we design and build code, if we can identify these pieces that seem to be drifting towards the same place and go ahead and merge those, we can solve a lot of these problems. We won't have to make updates twice. We won't have to, solve one bug and then everyone feels like they're taking crazy pills when it pops back up again in 2 weeks. And why? Well, we fixed it in this API, but we didn't fix it in this API that this other page used that feels like it's doing the same thing. So taking the time to figure out how we can merge these things together, directing the code from an architecture perspective and directing the product into smaller, more reusable bins can solve some of these problems. I also call out libraries specifically. I know I'm guilty of this a lot, especially early on in building software products. It's so easy to find, we want to build a new feature. We search, we find a great Stack Overflow example that imports 3 libraries. We copy it, it works great, and we're done. We move on from the feature that we're building. The problem with that is, and I found this a number of times, you may end up having 3 different libraries that actually do the same thing. And I've run into this in some projects. CSV parsing is actually one of these that I've dealt with a lot. JSON parsing in Python, again, is another thing that I've run into this with. And pulling out some of these libraries and reusing them actually leads to avoiding some very weird issues. 2 different implementations of the same standard JSON may actually net out 2 different types of results, or may have 2 different types of inputs they can accept. And using one will break, using the other, it will understand it just fine. Or you may end up building on, bugs in the library. This particular library has an issue when it encounters this type of data, this other library doesn't. And if you've built around that bug, trying to change libraries or trying to use it in a different part of the app may not work, even though it works fine in other places. And dealing with those issues are not only frustrating, but slow us down a lot as a team. And if we're not careful, they can also lead to weird inconsistencies and issues. One other consideration with libraries as well is supply chain security. As supply chain attacks are on the rise generally in our industry, being very judicious about libraries, using libraries that you know and that you've trusted and investigated, actually ends up leading to more secure code as well. So approach 4 here, following best practices. This seems like a no-brainer, but I think usually in the moment, and when we're working on very specific problems, it's very easy to find a way that works, like hack through it, get it solved, and you're done. It's hard a lot of times to take a step back and realize, oh yeah, we're using this pattern that has been solved 30 years ago, and maybe dust off your Gang of 4 design patterns book and dig through it and understand, like, hey, this may be a really good model that we can use that also seems extensible and battle tested. And I think in a lot of ways, most of the software we build isn't actually solving brand new problems. We occasionally encounter brand new problems and have to come up with ingenious solutions for it. And those are really exciting and those are really fun. But most of the time, it's really boring things that we have to do. Like, we need to build yet another API that takes in REST data, that maybe saves an object to a database. And if we're judicious about thinking about those particular strategies and reusing patterns that either we've reused in the code base before, or that we've reused in industry, or that are very common, we can avoid a lot of these problems. And the reason being, a lot of these techniques that are industry best practices are standardized. They're designed either over time or, by guidance from a industry or design body to work together and to be widely supported, and may have a lot of pre-built interfaces that we can use later, may already be heavily tested, may already be segmented, and have really good APIs and contracts between components that we can reuse and base our software and design principles off of. And one other thing to call it here is, a lot of times when you're running into these best practices, a lot of times the specific examples are very dated, but the concepts are usually still relevant to what we're doing. A lot of the problems that we're dealing with have roots in problems that we as an industry have thought about, many years ago. Another thing that I think is really hard for us to do actually as engineers when we're in this iterative mindset is doing the hard thing. So if we encounter a problem or encounter something that we don't fully understand, we may try to find a way around the problem. Do we need to pick up another technology because this particular database isn't good at this one thing? Probably not. And that leads to, technology and platform bloat. Do we need to pick up a new language because it's better at one task for this one issue? Probably not. At some point, it gets to the point where we do need to actually refactor our code base. Maybe it is worth eventually rewriting all of our front end from view 2 to view 3. But we do have to be very careful about when we pick those problems. And when we do it, we also need to not increase our surface area. A lot of times, if you encounter some of these hard problems, there is a way around it in the technology or framework you're using. And picking that solution may actually allow us to be faster and more agile and build a better product in the near term and allow us the space to later make the bigger technology decisions or make the bigger technology shifts because we haven't tried to do it piecemeal. And another side of this is a lot of times this can come from adapters. And adapters increase surface area, but a lot of times it's a lot less code than building a whole nother layer into your application or your tech stack. So the last thing that I want to touch on here, as far as approaches, is take 10% more time when you're building. I think if we all are working in this very iterative process, it's very easy for us to have conversations around, can we do more in the sprint? Can we ship another feature? And those are really difficult conversations because all of the features that we're building are really important and have some value to the customers. So if we kick one out in favor of spending a little bit more time and building things that we are currently working on better, it's a hard sell unless we're good at explaining the risks to the stakeholders. And this is one of the cases where it's on us as engineering leaders to make the case and to be able to sell that, because we're the only ones that can, and we're the only ones that actually know the impacts. And some of the ways to do this are, think about your team. Like, don't just jump into a problem. Get people to talk about hard problems. And if you take the extra time to plan, you may end up with a much better solution. And by filtering it through your teammates, obviously, they're going to color how you build it. You're going to have to think about how they understand what you're building. You're going to have to share your ideas. And not only does that help you build code that your entire team can work on and facilitates knowledge sharing and brings everyone together, it actually allows us to elevate these problems. If we discover a major issue in what we're building, a way that we're approaching it, something that can increase surface area, we're all aware of it and we've talked about it. And it allows us as leaders to basically ask our team, either in retro or ad hoc, to say, what do we need to work on? What is slowing us down? And they know. And we can make the space, we can fix it, and we can improve our team. And the final example here, when we're building stuff, we should always imagine the new hire picking up where we left off. If we're writing code, we're building technology, and we're shipping new features, we may not be the ones to pick it up next. Oftentimes, we're not going to be the ones to pick it up next. And taking the extra time to document, to not try to pack too much stuff into one line, to simplify exactly how we're using things, and spend some time thinking about architecture of the feature that we're building and how it relates to the application as a whole will reduce the cognitive load the next time the new person has to pick it back up. I'm generally of the mindset that humans are very bad at remembering large lists of things. Even myself, if I go back and pick up code that I wrote 3 weeks ago, I probably don't even know what I was thinking. So this applies to everyone in your team. And if anyone is able to pick up any piece of code that you write, they're going to be faster, they're going to understand it, and you're actually going to be able to manage a lot larger surface area with a similar amount of people if you're good about how you structure and write your code. And I'll caveat all this by saying at the beginning, I said take 10% more time. We should not, spend 3 times as long to overbuild something. That is getting to the side of too much engineering. But taking a little bit more time to think about these things can actually have tenfold benefits. So I'll do another check for questions. Looks like there aren't any so far. And I'll close today basically by saying this. The solution to this particular gradient descent problem, this local minima problem, is that we have to think past to the next iteration. If we think too far past, we may be overbuilding and get into trouble. If we don't think any past, we'll also get in trouble. So the balance here is actually more of an art. We do have to think ahead. We do have to understand where we're going directionally as both a company, as a department, as a team, as a product, to make the right decision on whether or not we spend extra time in this area or we continue to iterate and actually leave it as is for now. And every one of the approaches that I talked about actually fundamentally requires looking past the current sprint, the current iteration. Everyone else does it. We have to do it as engineers. Product teams plan roadmaps. Businesses define yearly and quarterly objectives. Technology leaders also have to do the same thing. We have to maintain our roadmaps, the things that we need to fix, the things that are slowing us down. And a lot of times, whereas product roadmaps and business goals are driven by customer acquisition or business objectives, the engineering roadmap can also be driven by things like making our team more efficient. Like, how are we able to continue to maintain the software? Will it scale? Is it on the verge of breaking down if we add 2 more users? And those are business concerns, but they're often slightly indirect and things that oftentimes engineering exclusively is able to see and advocate for. So this is where we as engineering get to advocate for ourselves, build a better product, build a team that actually works really well, is really efficient, and is, working on a product that's easy to work for. And as I mentioned before, engineers, I'll say stereotypically, not everybody, are often bad at communicating. While that's a trope that may or may not be true, I do think it ends up being difficult for us when we're in a business context to outsell these problems when we're going up against people that do it for a living, product people that are with customers all the time, sales leaders that are professional at getting their ideas across and convincing people of stuff. And we have to be just as good. We're all advocating for the same thing and rowing in the same direction as a company. And we just need to take the time to figure out how to communicate these things well. And finally, surface area is a major problem for our products, our engineers, the things we're building, and it is actually a primary business outcome. It impacts our efficiency, our bottom line, our ability to deliver on new features and customer commitments. And it's very important that as engineering leaders, we take the time to understand it, understand the risks that come from it, and advocate for solving it so that we build a better product and build a better company. So that's it.
We do have a question for you.
Oh, yes. What do we got?
Yeah, the question would be, what are some metrics that we can use to evaluate the size of our surface area and to track progress as we improve as business?
Yeah, that's a really great question. As I mentioned, I didn't get into specifics here, and it'll really depend on your business. This is a thing that you need to understand by the people that are building the software. It could be, I've seen a couple of different ways of thinking about this. You could just have too much code. If you are a small team working on a very broad product, it could just be number of features that you have, like features divided by number of engineers. It could be something as simple as the number of lines of code of a particular type. It could be, as I mentioned before, I had one company that I worked with that had way too many microservices, and it was hard to get started in. So it could be, at some point you feel that something is starting to get overwhelming, or something is starting to break, or something is starting to have a lot of bugs or feel fragile. And these feelings tend to come out either in, a preponderance of, say, bug reports, major dissatisfaction with particular parts of the application or developer experience and retrospectives, and a number of places. So, I would love to be able to provide like some specific metrics, but there's actually a couple. And a little bit of a shameless plug. One of the things we're building at Allstacks allows us to track a bunch of different metrics in your code base and surface area, and allows you to, identify where those issues are, and allows you to pick between the metrics that seem to be the hardest thing to work on right now. And if you find something that represents a major surface area risk, track it, improve it, move on to the next problem, and continue to maintain it. But it's going to be a little bit contextual to your business, exactly what represents difficulty for your team to manage. Anyone else? The remaining time here is for Q&A. Feel free to ask me anything, and I'm happy to spend the time trying to answer your questions. I imagine a lot of you are very talented at this and have some really great thoughts, or maybe have something to add, and I'll be happy to talk about whatever's on your mind. I guess everybody is just, really relieved to not have to fly and get to spend time with their family, not have to go to this crazy conference down in Florida. Well, I'm not seeing any questions, so I'll leave it here. Feel free to drop me a line. You can find me on LinkedIn. My email's pretty public, and I'll be happy to talk about any of these topics at length. Is there anything that we want to close with, Paulo?
No, I think we're good. We'd like to thank you, everybody, for your time, and hope everybody's safe and enjoy the rest of your day.
Ditto. Thank you all very much. Hope you have a wonderful day.
Bye-bye.